Hi, we are a part of the Aerospace Technologies VRP, and we are KL, and we are working on a low-cost satellite for Hawaii observations with artificial intelligence. I'm Evan, and also the financial manager.
Preston.
I'm Nicholas.
I'm Adam.
I'm Sean. I'm the project manager.
I'm Kenny, and I'm the system integrator.
And I'm Christiane.
We're advised by Dr. Miguel Nunez of the Hawaii Space Flight Laboratory.
So the goals of our project are to create an inexpensive satellite that can take a picture of the Hawaiian Islands. We also want to utilize artificial intelligence to recognize those pictures taken.
So this video is going to cover the technical breakdown of our satellite. Here we have an exploded view of the CAD model we have, and it has all of the subsystems that we're about to talk about. We will go kind of fast through everything, but feel free to pause the video at any time if you want a more detailed look. The first subsystem we're going to look at is structure. So structure encompasses the design and validation of a lot of the structural and mechanical components inside the satellite. We also manage internal packaging with all the different boards. And on the bottom, you can see one of our antenna tests. And to the right, you can see a bunch of our CAD models.
So next we're going to talk about the thermal control system. So the goals of thermal are to maintain operational temperatures of each component. On the table on the right, you can see that for the battery, we want to keep it between 0 and 45 degrees Celsius. To do this, we use temperature sensors and heaters. And on the bottom, you can see a model we made on Thermal Desktop.
Next is the Attitude and Determination Control System, otherwise known as the ADCS. The ADCS is responsible for controlling and determining the satellite attitude or orientation. 3 attitude actuators generate an external torque, which allows us to be able to control our satellite in any direction. And because of COVID-19 this semester, we've been working on Python code for models to be able to control the ADCS. On the right is an example from our controller model on Python. So these two graphs represent the control from our controller model represent the attitude vectors over time. Each quaternion or each Euler angle represents a component of the attitude vectors. And the purpose of our controller model is to tumble the spacecraft by a specified time so we can point it in the direction that we desire.
The EPS, or electrical power system, of our satellite consists of the batteries, power distribution board, and solar panels. The EPS is responsible for generating and distributing the power. We also fabricate the board, so if you're interested, hit us up. Our satellite will use up to 0.99 watts per orbit, and it can generate up to 1.77 watts per orbit. Next, we have our charts of our satellite generating power and balancing the power through a single orbit and a 24-hour day.
Next, we have the onboard computer subsystem. So the OBC subsystem is responsible for writing all the software necessary to run the satellite. So to do this, we use a program called Cosmos, and we create different agents with Cosmos. On the right, we have an Eagle model of the OBC, and below we have the actual OBC.
Next up, we have the payload subsystem. So on the right, you can see our camera that we chose from last semester, which is the Caspa VL. And we have these different boards that help control the camera as well. We're planning on taking an image of the Hawaiian Islands using OBC, Cosmos, and artificial intelligence. And we also want to be able to transmit the image over comms and ground station.
And lastly, we have the communication subsystem. So in this subsystem, we deal with the contact between the ground station and the satellite, and we're utilizing a network called SatNogs, where there are ground stations all over the world that are able to receive data from satellites in the form of audio files and waterfalls. So on the screen here, there's a picture of one of the waterfalls that we received from our ground station. And the equipment we use in a ground station is a Raspberry Pi 3, RTL SDR, and a telescopic antenna.
So the goals of our project for 2021 are to develop a machine learning algorithm, as well as apply for CSLI. On the bottom, you can see a quick timeline of what our next semester will look like.
Okay, thank you so much for listening, guys. I know this was really fast, but if you're interested in our team, please feel free to scan the QR code, and please have a nice day.